Hello, everyone. Thank you so much for taking your valid time for attending Techno Day today. Thank you so much, Jen Ashley, for giving me this wonderful opportunity to present for Techno Day. So, welcome, everyone. My name is Deepthi Goguri. Today, I would like to present on the topic Introduction to Query Store on-prem and in the cloud. So, basically, Query Store is released in 2016 and it has wonderful benefits. If you are on 2016 and above versions of SQL Server, make sure you use it. Use this wonderful feature, and you'll know why it is so important in this session. Myself, I'm Deepthi Goguri again. I'm a Microsoft certified trainer and Microsoft certified solution expert. I did my master's in computer technology at Eastern Illinois University, and also I'm an organizer for a couple of user groups. I'm an organizer for diversity, equity, and inclusion user group, and also Microsoft Data and AI South Florida user group. I do volunteer for Women in Technology user group as well. And apart from my work and the community work, I love arts and crafts. I love making things with my own hands because it gives me lots of peace. And if you'd like to get in touch with me later, uh, if you're on Twitter, at dbnuggets is my user ID. If you're on LinkedIn, just search by my name. And I do have a blog where I usually blog about SQL Server. dbnuggets.com is my website. Please do visit. So, what are we going to cover in this session today? We are going to see the introduction to the query store. What is query store? And one of the benefits of having the query store is plan forcing to quickly solve the performance issues. That's one of the benefit. But when you start like using the plan forcing, you might be also see couple of the failures due to some reasons. We are going to see what are those reasons and how to monitor them. And also we are going to see the enterprise edition of SQL Server feature for Query Store, which is automatic plan correction, which is available in Azure SQL DB by default. So we are going to talk about that as well. So what is Query Store? Query Store is a feature in SQL Server which got introduced in SQL Server 2016. It captures the execution plans for your queries. So when you turn on the query store, basically this is not a server level feature. This is a database level feature. So you need to enable at the database level on each of the database. You want to capture those execution plans. You need to enable them. Once you enable the query store, it will go ahead and capture all of your queries, query text, query ID, execution plan information so that you can go ahead and easily monitor back in time when the query has run and what execution plan it has used and whether it is optimal or not. If, for example, the query is continuously generating different execution plans, it is like a one-way shop where you can go ahead and see all of those execution plans for your queries and then simply go ahead and force a plan which you think is optimal. This is especially useful when you have those um, parameter sensitive queries to fix the parameter sensitive queries very quickly without changing any underlying code. Cool, right? So we are going to learn about that more. So it's a database level feature only. Like I said, we need to enable it. It is disabled by default in SQL Server and by default on SQL Server. You need to manually go ahead and enable on the database. And it is also disabled by default on Azure Synapse Analytical Database. But if you have Azure SQL Database, it's enabled by default. And you cannot enable the query store on master or temp DB. So how query store actually works behind the scenes? This is very interesting. So let's say you have a query and you are going to run on the SQL Server. So when a query is submitted to the SQL Server, it will check if it is running for the first time, right? And if it is running for the first time, it will go through the compilation and the optimization phases and it will generate a new execution plan. But in the other side, if it is not running for the first time, right, it will go ahead and check if there is already a plan in the plan cache. If there is no plan in the plan cache, then it will go through the compilation and the optimization phases again to generate a new plan. But if there is the plan already in the cache, all right then it will go ahead and take it from the plan cache. But wait, before moving forward, it will check for the recompilation. So, for example, if for some reason your query has generated, a new query plan has generated, even before moving further, let's say you force a plan by using the query store. In this particular scenario, that query which you forced a plan, right? It will go ahead and check if the plan that has been taken from the cache or if it was generated newly, whether it is same as the forced plan because you forced a plan for this query, whether it is the same like the forced plan. Oops, no. If it is not the same, then it will go ahead and it will go ahead and apply the force plan. But if it is similar to the force plan that we forced, then it will go ahead and move forward. So next thing, what happens is even before execution, the query text and the query plan for that particular query will be saved in the memory. So there is this part in the memory, there is a store. When you enable the query store, there are certain stores where your query text, query plan will be saved. So that store is known as plan store. So that is saved in the memory asynchronously. Once that is completed, again, this is before executing the query. It will go to the execution phase after saving the query text and query plan inside the plan store in the memory. So once the query executes, then it will go ahead and save the runtime stats in the runtime stat store because runtime stats always get captured after the query executes, right? So it will go ahead and capture asynchronously after the query executes in the runtime stat store. So once that is done, one so there are a couple of settings in the query store, like the flush out intervals. So once that flush out intervals has reached, or sometimes you do not have to reach the interval. When there is a memory pressure in those kind of scenarios, all this query text, query plan, runtime stats that has been captured in the memory will be flushed out to disk. So where it will be flushed out to disk, it will go ahead and save that data asynchronously in the query store schema. So when you enable the query store, it will have the query store schema within the database that you enable. It will go ahead and save there. And by using the system views for the query store, you will be able to query the data that has been captured here. That's how the query store will work behind the scenes. Now, you might be having question, hey, but we have the plan cache, right? Why do we need to enable the query store and capture all of this information? Right, I agree. We do have the plan cache, but let's go ahead and see the differences between the plan cache and the query store. When you have a plan cache, whenever you restart the SQL Server, all the queries that has been captured, like the least recently used query plans that has been there in the plan cache will be flushed out in whenever there is a memory pressure. But it will be flushed out every time you restart the SQL Server. But that's not the case with the query store. All the data will be retained based upon your cleanup policy. So the cleanup policy that you set for the query store, it can be anything that you put on based upon your needs. But the default is 30 days. And if you are using the plan cache, it will store the latest plans, right? Whenever there is a memory pressure, the least recently used queries will be flushed out. So you always have those latest plans. But with the query store, the plans will be captured over time. And when you have a plan cache, just like I said, it will be evicted based upon the memory pressure. But with the query store, until the flush out intervals has been reached, all the data will be captured in the memory, like we have seen in the previous slide, how the query store works. It will capture and it will push that data that has been captured to the query store schema later. So it is very difficult to know why the plan has changed if you are using the plan cache. But by using the query store, it will be very useful to troubleshoot the performance problems because you can go ahead and see what was my query plan at that particular time when it has run the query. You can go ahead and see the history of the plans. So what data is collected by the query store? SQL Server 2017 and plus, they have included the new wait stats information. So when you are in SQL Server 2016 and using query store, you do not have that wait stats information. And it will store all the information that you are seeing here, like query text, query ID, query plan, CPU, IO, memory, wait stats information, like how much memory has been used, right? How much of my temp DB has been used, all of that information, along with the execution plans, history of the execution plans. And by using the query store, one of the benefit is like you can go ahead and easily pull the report for the top resource consuming queries for you. So let's see how to enable the query store and what are the operation modes. So once you go right click the database, you'll go and see in the properties. Left side pane, if you see here, there is this one um, tab query store, right? If you are on 2016, it will be available. But if you are on before 2016, you won't see that. So click on query store where you see three operation modes: read write, read only, and off. When you put it is off, which is by default off, that means query store is not enabled, right? Of course. But if you are putting it as read write, all the information will be written, like the captured information will be returned to the database in the query store schema. But if you put only read only, then it will go ahead and read the information of the force plans, but it cannot write any information into the schema. So there are a couple of capture modes. So you have turned it on to the query store into read write, let's say, for example. Now you have to go ahead and choose the capture modes. How do you want to collect the data? Like what queries do you want to collect, right? It's really important. If you choose all here in the capture mode, it will go ahead and capture all of the queries, even the insignificant queries, everything. Even the queries that you are not even bothered about, they are running pretty fine, quick. Those things also captured. But the main intention of enabling the query store is to capture those low performing queries, right? So all is not an option, but auto, if you choose auto, which is the recommended mode by Microsoft, if you place an auto, it will go ahead and capture the significant queries that you might be looking for. So there is this inbuilt algorithm where it will check for the query if it is running certain amount of time based upon certain CPU threshold, those kind of information. We do not have access to that, but based upon that, the queries will be captured, which is recommended. Again, this is auto is by default from 2017, but if you are in 2016, you have to go ahead and turn it to the from the all to auto, because in SQL Server 2016, all is um, all is by default. You need to change that to auto. And when you choose none, none of the queries will be captured, but your query store will be turned on, but none of them will be captured. And when you choose custom, you can go ahead and set the customized capture policies. Now, what are some of the query store options? Cleanup policy is by default 30 days, meaning it will capture the information for 30 days. And once the 30 days has been reached, it will go ahead and delete the oldest data. Data flush interval in seconds is 15 minutes by default. So like we have seen, this flush interval will push the data that has been captured in the memory every 15 minutes and push the data into the query store schema. But sometimes when there is a memory pressure, it might push the data early than the data flush intervals. The maximum storage size is 100 MB by default for SQL Server 2016 and 2017, but it is 1 GB for 2019. Again, you can change these default. For the complete list of options, see the doc down below. But we are also going to talk in our demo. What are the query store benefits? So like I said, you can capture all of the query information. You can capture the execution plans. So whenever there is a performance problems, you can go ahead and see the top resource consuming queries, how much resources they took, and you can easily compare the regression between the execution plans. If there are like parameter sensitive queries or other queries that have been generating the new execution plans all the time, but one execution plan is working better than the others, you can easily identify those regressions here, and then you can go ahead and force the plans. Again, forcing the plans is not a permanent solution. The permanent solution is to always work on those queries with the developers and as a DBAs working to see how to improve the performance without even forcing. Because once you force the plan, that doesn't mean that it will stay the same, right? It is still the effective best plan down the road. It might A new plan might be generated, and that plan might be more beneficial than the last force plan. So you need to go ahead and look into how the force plan is working, whether it is still optimal or not, those kind of things if you force a plan. So the ultimate goal should always be to work on the query, but sometimes you do not get chance to work on the query very quickly. In those situations, query store will be very beneficial. Again, for the performance tuning, it will be very beneficial. You do not have to change any underlying code. All you have to do is force a plan that you think is optimal to use. And personally, I used the query store for the database upgrades. So we are going to see um, how I use query store for the database upgrades. We will see in the demo. So there are three main stores we have, like we have seen in our how the query store actually works. We have plan store, runtime start store, and wait start store. Plan store will obviously it will store the plan information. Runtime start store will collect the runtime stats information, and wait start store will collect in a categories of this wait stats information. Let's go ahead and see how to force a plan. Again, this is just a slides we are going to see in our demos as well. So just like the use plan query hint, the plan forcing can be used to um, to force the optimizer to use the best plan among the other different plans that got generated for the same query. But once you force a plan, there might be couple of failures. There might be failures because once you force a plan doesn't mean that the optimizer have to use that all the time. There might be cases like whenever you do the index optimization or the statistics updates, there might be changes to generate a new execution plan. In that case, if there is a new plan that got generated and force plan cannot be used in that situation, then it will go ahead and show you the failure reasons as well. But to force a plan, SP query store force plan is used, that store procedure is used. To unforce a plan, SP query store unforce plan is used. Again, while I said the failures, we are going to talk about those failures as well. Monitoring the failures, right? Like whatever objects you are using inside the force plan, if you modify any of those objects, let's say as a DBA or a developer, you have that ability to go ahead and force a plan. But there are other developers in the company, and they might have thought that, hey, this index is not being used. Let me go ahead and drop it, or let me go ahead and change it, add a specific column into that index without the knowledge of like what effects it might cause for the force plan. But that particular index is being used within the force plan. What will happen in that situation? Do the query fails? No, the query doesn't fail. That is a very good thing about the query store. The query, no matter if the force plan is used or not, the failure reason will be captured within the query store, but the query itself doesn't fail. It will go ahead and successfully execute and capture the failure information, whether there is no plan associated with that particular um, index. If you drop the index, right, there will not be any plan in that index, in that plan. So in that case, we'll see um, no plan, no index failure reasons. We will see when these particular failures are being shown in our uh, in the in the failure reasons. We'll go ahead and see that in our demo. So how to monitor these failures if you have? By using the Management Studio, you can go ahead and open up the query store within the database you enable, and then go ahead and see queries with the forced plan. By that way, you can see the failure reason, but also you can go ahead and use the catalog views. You can query the catalog views to get that information as well. What is this automatic plan correction feature? Is used by the query store. So this particular specific feature is enabled for the enterprise edition only, and you do not have to manually force the plan. It will go ahead and automatically monitor and force the better plan for you. It is only available in enterprise edition as well as from 2017 plus. So what the automatic plan correction does is it will go ahead and continuously monitor and find the regression between the execution plans and automatically force the last good plan for you. For example, let's say it continuously monitored and it forced a plan, but then later it won't stop there. It will go ahead and continuously monitor, and then if at all if there is a new execution plan that got generated and useful, it will go ahead and unforce the old plan and then force the newly generated good plan. And it's a continuous cycle, right? It would not stop there. Automatic plan correction is enabled by default in Azure SQL DB, but you can go ahead and turn it off if you do not like. But here, by using the automatic plan correction, what is the benefit? The benefit is that you do not have to monitor continuously. But if you are using the forced plan, you have to monitor continuously because there is no automatic correction for that. Later down the road, there might be a new plan got generated, and it is very difficult to even know what plans you have been forced, right? So it's very important. If you have Enterprise Edition, go ahead and try this out. And how to enable this, right? You can enable it by using the T-SQL, by using the alter database name, set automatic tuning, force last good plan to be turned on. And you can also see the recommendations, like why the automatic plan correction has actually chosen a different plan and why it has actually forced. By using the systemdb tuning recommendations, you can see all the recommendations, why it has actually forced a plan. In the Azure portal, to see whether the like to enable or disable forced plan, right? If you are in Azure portal, this is already enabled. Like you can see the force plan as turned on. Under the Azure SQL database, go to the automatic tuning. Once you open up the blade, you see force plan. This is automatic tuning, right? Not only the force plan, you have create index, drop index. These are the automatic tuning features available especially for Azure SQL database. So it is all already enabled, but you can go ahead and turn it off as well. Let's talk about the query store hints, which is in the preview mode. So let's say you have you have a parameter sensitive query, and once you execute that query for the first time, it will go ahead and generate an execution plan, right? The next time you run the query with any parameter, it will go ahead and use the same execution plan from the plan cache, like we discussed previously. But what if your query has first run with a not so good parameter? It only generated hundreds of rows. But the next time you run with a parameter, it generated million rows. Now, what will be the problem here? It might do an index seek in the previous execution in the plan, but now it needs a scan because it is pulling up 1 million records, right? So but that will not be the case. It will go ahead and take the plan from the cache with the seek in it, and that will cause the problem, index, the performance problems, all kind of things. But by using the query store hints, you can go ahead and just capture the query ID for that store procedure, and then what kind of query hint you want to use, you need to provide. Now, what do you think which query hint will be beneficial here? Let's say you do not have a query store, right? You will be placing the recompile option, right? That for that thing to happen, you need to modify the query itself. But here with the query store, you do not have to modify the query. All you have to do is there is a store procedure especially available for query store hints. Execute the store procedure along with the query ID for that store procedure and provide the hint which you want. It will go ahead and automatically sniff the parameters and recompile the next time the query runs. How cool is that, right? So what kind of query store hints you can use? You can use max stop, recompile, maximum minimum, memory grant size, compatibility level as well. You can use it. So how to actually um, put a query store hint on a query ID? You will use the store procedure sp query store set hints and you'll grab the query ID by using the system catalog views for the query store. By using the store procedure sp query store set hints, give the query ID and then value. The value here we are using is recompile. So what we did do here, we have actually cleared out our procedure cache. Now we wanted to go ahead and see what's there in my query store. This is the catalog view where we want to see. And if you see here, let me run it again. So everything is there, right? But if you see what's there in my procedure cache, you won't see anything because I deleted. So that means the data will be retained even after the procedure cache has been, plan cache has been, cleared out. So let me go ahead and clear out my query store by altering the database name, set query store clear, will clear out my query store. Now let's see how the query store, how the ad hoc queries will be added and saved in the query store. These two are the similar queries if you observe, but the only difference is the product IDs, right? And each query is executed twice. So let's go ahead and run these ad hoc queries, execute, and then go to the query store and refresh. Here is a refresh button, refresh. Now, if you see here, these two are the same exact queries with the two different parameters. But if you observe here, both of them got the two different query IDs, the same exact query with the different parameter values. So imagine if you are sending so many ad hoc queries for your SQL Server, imagine it might easily blow up your query store because the query IDs will continuously grow up and blow up your query store. So that is the reason why it is so important to parameterize these and put these queries in the store procedure. Even the slightest change, even the slightest space can cause the issue. Here, if you see, I have added a little bit of space. And if you run here again, if you run here again, and if you see the query store, if you refresh here, you see a different query ID, the same exact query with the slightest change of adding up a space. So it might easily blow up your query store. So that is the reason it is so important to put these kind of queries if you are running them multiple times into the store procedure. So I'm adding the same exact query by adding the product ID as a parameter and placing that query in the store procedure. So let me execute that and create the store procedure. So we have created that. And let's go ahead and clear out the query store. So everything we are starting it as fresh. Let's clear out our procedure cache as well, right? And then execute the store procedure with two different parameters this time and see how it will be stored inside the query store. So I executed, go ahead and refresh. Now if you see here, the store procedure has been executed twice. But if you see here, only one query ID has been captured. And there are two execution plans, right? Here, if you see, those are two different parameter sensitive, uh, sensitive query. for that store procedure. So that is the reason why you have seen two different plan IDs has been generated. And if you hover your mouse over it, you can easily see the total duration is 6.62 for the plan ID number 1. For the plan ID number 2, it took 1065 milliseconds. So there is a huge difference between these, right? One is doing the clustered index scan and the other is doing a index seek and the key lookup. Let's say I wanted to use this particular execution plan because rarely the scan will be done. Let's say for this store procedure, I would like to force this plan ID number 1. So just go ahead and select the plan ID and then go ahead and click on force plan. So if you go, it will ask you whether you wanted to force a plan. Let's say yes. So this particular plan 1 is currently being forced. Now the next time I run the same store procedure with any different parameter, right? We are using a different parameter here and execute it and refresh it. No new plan will be generated. And if you see here, um, let's run it again by enabling the actual execution plan on. If you execute it here, the index seek and the key lookup plan is being used to see whether whether the force plan is being used. Go to the properties and then see here the use plan is currently being true. The use plan is true, meaning it is using the force plan. Now let's go ahead and place the query store into the read only. That means it won't capture any information, but it will use the force plan information. Let's go ahead and clear out our procedure cache and then execute this particular store procedure with any parameter. Remember, it is currently being forced. Go to the execution plan and see it's still using index seek and key lookup. That means here, if you observe, we have cleared out our cache, right, before running this, so that there is no plan in the cache. So it generated a new plan similar to the forced plan. That means it is using the forced plan information, no matter even if you put it in the read only mode. So now let's go ahead and turn it off, turn the query store off. That's my first demo. Now let me go ahead and show you how I use the query store for the database upgrades. So let's say you have a database in the older versions of SQL Server, let's say 2012. I have upgraded that to 2016 and we are using wide world importers data warehouse. So before beginning, let me go ahead and free up the prop cache here. And then I'm turning the query store on for this database. Let's say we upgraded the 2012 database into 2016, and then we are enabling the database here. I'm in the meeting. I'm in the meeting. I'm in the meeting. Please. So enable the query store and then the options for the query store. And then still put the database in the older versions of SQL Server even after the upgrade. Why we are doing that is because we want the database to be work just like the way it used to work in the older versions of SQL Server, so that you can capture all of the queries just like the way it used to run in the older versions of SQL Server. So I have placed the compatibility mode as 2012, enable that, right? And now go ahead and capture all of the information, um, capture all of the execution plans and run those queries, run those stored procedures, right? So let's say we already have this um, stored procedure in the database. Here I'm creating one. Now, since our database is in the older versions of SQL Server 110, which is 2012, I'll go ahead and clear out my query store and prop cache, and then I'll run the store procedure. So if you see here, it executed the store procedure. So let me see whether it is being captured. If you refresh, You see the query store, top resource consuming queries. If you see here, this query has been captured, right? The plan ID 2 has been captured. That's in the older versions of SQL Server. After the upgrade, we placed the database in 2012 mode. Now, as we captured that information, now let's go ahead and upgrade that to 2016 mode. And then run the store procedure one more time. Now, why we are doing that? How does the store procedure work with the newer version of SQL Server? Once I done that, if you go ahead and refresh, for the same stored procedure, it has actually generated a new plan in the latest version of SQL Server. Now, the stored procedure might work properly because we upgraded, right? The new features will be added and most of the queries will work perfectly fine in the newer version of SQL Server. Like it will improve the performance. But sometimes we might also see the other side, like they might be performing slow. In that case, you can go ahead and easily compare here. Now, now it generated the plan ID 3. If you hover your mouse over here, it took 5.31 milliseconds. In the plan ID 1, which is in 2012 mode, it took 7.67 milliseconds, which is like clearly we can say that the query is performing fine in this situation, right? But it might go in the other way. When I did the database upgrades, I have several queries that were not working fine, where I easily went ahead and forced the old good plan from the older compatibility mode. Because I captured that information by using the um, capturing policy, right? By enabling the date query store and by placing the database in the older version, even after the upgrade, just to capture how it used to work and those older execution plans so that you can easily compare the regression and force if necessary. So that's how I use for the database upgrades. Now let's go ahead and see our third demo, which is query store failures. Now we have forced a plan, but now we wanted to um, see the failures, right? Now let's go ahead and clear out my query store and then procedure cache on the wide world importers database. And here, if you observe, previously we executed a store procedure for this particular database, right? It it needed an index, supportive index. So I have created that supportive index, and I'm running the store procedure again to see if the index is currently being used. Execute it, and then go ahead and refresh. Top resource consuming queries. If you see here, right, the plan number 3, if you see the plan number 3, it is clearly showing that the index seek is being used and that particular index is being used, right? Now what if I go ahead and drop that index, making modification to that object within the force plan? Now I'm going ahead and dropping the index and then run the store procedure again. Will that cause any issue? Like we said, the query absolutely executed fine. But what happens with the failure, right? Where does it get captured? Go to the query store again and queries with the force plan, right click, view queries with force plan. If you see here, refresh. But I forgot something that we need to force this particular plan we need to force because once you force, then only it will capture the failures, right? So let's go ahead and force a plan that it was using the index. Now let me go ahead and execute this. And view queries with the force plan. Now if you see here, there is force plan failure count 1. Now what is the reason? There is no index, right? There is no index associated with this particular force plan. That is the reason it failed and it showed as no index because we dropped that particular index. Now, what if I go ahead and um, recreate that index as is, right? I dropped it and now I wanted to recreate it and then execute that plan again, execute that stored procedure again, execute to see again it is being used. There is no problem for it to go ahead and use that index seek again. And then you can go ahead and see um, um, what if you go ahead and alter the index this time, adding a new column, right? So I'm altering that and then and then executing this again in the top resource consuming queries. Again, if I see here, right? If you see here, I altered the index. Even alter will also cause the failures, and the failure reason is number 2. And what is the reason? No plan. There is no plan associated with that particular altered index. So that is the reason we see this failure. So these are the failures. This is how it will get captured. Let me go ahead and close all of those so that I can open my new demo. Automatic plan correction is especially used for Enterprise Edition, and in Azure SQL Database, it's already enabled. So I'm connecting to my Azure SQL Database here, and then I want to make sure the automatic plan correction is turned on, which is by default it's turned on, but I wanted to make sure. So it is executing. I place the database in the serverless mode. That means the database will be paused when I am not using it. So when we are using it again, the first few executions will cause the failure, but then the third execution will be perfectly fine. So I'm just seeing whether it is going to set the database, right? This might cause the failure, but let me go ahead and change it to Adventure Works here. And then it is taking a while to capture that. See, when you put the database in the serverless mode, the database can be paused. It will save a lot of resources for you because only when you are using, that's when you will be charged. It is very useful for our demo purposes because it will save our credits, right? So I'm altering the database, setting the database again. Now this time it worked. Now I'm going ahead and creating that stored procedure that we have created earlier, the same stored procedure. We are still using AdventureWorks database even in the Azure SQL database. So it's executed successfully. Now I'll go ahead and clear out my procedure cache and query store just in case. Now this is automatic plan correction demo. So what we'll do is we'll go ahead and run this particular store procedure with this parameter 50 times. Because automatic plan correction will only work with by continuously monitoring it, only one execution might not work. It will observe many execution of the stored procedure and then decide which one to choose. So I'm going ahead and executing for 50 times. I'm executing it and I'll connect to the Azure SQL database this time. Refresh to see the query store. Top resource consuming queries. If you see here, we have executed it for 50 times. And that is the reason you see the bigger ball here, bigger circle. Now I'm going to clear out my procedure cache. This is a parameter sensitive store procedure. So with these two parameters are very sensitive. So I'm creating the regression. So I'm running this execution plan for 10 times. Now why I'm running for 10 times? Let's see the number of records that it is pulling up. The first execution, with that different parameter, it only created 300 rows. But this time for each execution, it has provided like something like 30,000, no, actually 237,000 rows, which is a huge difference in the records, right? So refresh and see there are two different execution plans that got generated. Now Let me go ahead and run the previous workload again because we want to clearly see the regression. I'm executing that. I'm going ahead and refreshing that. If you see here, I did not force any plan, but if you see here, the plan ID 1 is currently being forced. It happened automatically. I did not make any changes. That's how the automatic plan correction works. It will go ahead and continuously monitor the regression between the execution plans and force a plan that is right and that is being optimal. That's how the automatic plan correction works. And let me go ahead and see um, what are the tuning recommendation, why it has actually forced that plan, right? By using this particular DMV, sysdmdb tuning recommendations, you can see the reason why it has actually forced. So it has forced for this particular reason. Average CPU time has changed. So it will change the it will force the execution plans based upon the threshold of certain amount of CPU. So that particular amount has reached, and that is the reason why it has actually forced a plan. That's how the automatic plan correction works. Now let's see the different last demo for today. So how the query store hints actually works. This is in the preview mode. So we are still using the AdventureWorks database as Azure SQL Database. So I'm connecting to Azure SQL Database. And then I'm going ahead and recreating the store procedure just in case in the AdventureWorks database. I created the database. And then I'm going ahead and clearing out my procedure cache and query store. And here I'm running two different parameter sensitive queries, the same store procedure with two different parameters. These are parameter sensitive. So I'm executing it with the actual execution plan on to show you the execution plans. So first we created the store procedure. If it exists, drop and recreate the store procedure and execute the store procedure. So the first time it executed with the 870 parameter, it has actually done the clustered index scan. So if you observe the number of records that has been pulled, the first execution pulled 360,000 records, but the second execution pulled 385 records only. But execution plan still shows the clustered index scan. Do we need, do we really need a clustered index scan for 385 rows? I don't think so, right? Because many resources being used. Now, why it has chosen clustered index scan is because it first executed the store procedure the first time. After creating the store procedure, it has executed with this parameter, and that is the reason why it has chosen the same plan from the plan cache, which might not be optimal when you are having parameter sensitive queries. Now, what will you do if you do not have query store? You'll just go ahead and recompile the plan, right? But by using the query store hint option, you do not have to modify the code because recompile option, if you want to do, you have to change the underlying code. But by using the query store hints, you do not have to do that. So how do you get the query ID? First, you need to capture the query ID first to even enable the query store hint. To do that, you can use this catalog views to grab the query ID. So the query ID is 1, okay. The query ID is 1 and we wanted to recompile that, right? If you use recompile based upon the parameter, it will go ahead and sniff and then create the execution plan based upon that parameter. So let me go ahead and execute that. So the next time you run the same store procedure, if you see the execution plans, now as we actually enable the hint, right? First, for that 350,000 rows, it used the index scan, but second time it sniffed, it used the recompile option, and then it only created the index seek and the key lookup. And then now you can go ahead and query the query store catalog views to see what kind of query hints are actually enabled for the query ID 1. The query hint ID 1 is used, and what is the query hint text? Option recompile. Again, if you are using this catalog, you will only see the latest hint that you are using. Like if you updated the hint, it will only show you the updated one by updating the query hint ID. So the next time you update it, it will show the query hint ID 2, but you will not be able to see the history of the information. But there is a way that you can capture that information by using the extended events, where you can go ahead and see the history of the hints that you have actually been used for that query. Now, instead of the recompile, I wanted to use a max.1 for the same query ID 1. Now let's go ahead and update that. So we are updating that, right, for the same query ID. Now go ahead and clear out the cache and then execute the store procedures again. Now if you see here, I have updated it, right, by using the max.1. So the recompile doesn't happen this time because we updated the query ID. So if you go ahead and see the properties, and if you see the max stop information, we have set to 1, right? So the max stop is set to 1 here, but the recompile won't be updated because we updated the query ID hint. Now here, I would like to add multiple query hints as well. You can do that. In the option, you can mention recompile and max stop 1. Go and execute that. And then run the same store procedures again. See the execution plan. This time, it has actually applied the recompile as well as max stop. Clearly, it shows the difference in the execution plan. It recompiled, but if you go ahead and see the properties, it also applied the max stop 1. Now, if you wanted to clear up the query store hints, you can use the store procedure sp query store clear hints will actually clear out everything for this particular query ID, the query ID 1. So I'm going to clear out and then query the catalog views to see if there are any enabled. It won't show up anything because we clear out the query hints for that particular query ID 1. So to see all of the information of what hints are actually um, actually can be used for the query hints, go to this link and you can see that, as well as in the Microsoft Docs as well. Those are my demos, and let me go ahead and show my slides back again. So there are key takeaways. As we have seen all of this information about query store, these are the key takeaways, important key takeaways that you need to carry with you. So basically, we cannot disable the query store option on Azure SQL Database, single database, as well as on Elastic Pool. There are two different trace flags that you can enable. The trace flag 7745 will actually avoid writing the query store data to disk before the SQL Server shutdown. So usually when you restart the SQL Server, it will happen normally, right? But if you have query store on it, all of the information that is in the memory have to be pushed to the disk before the SQL Server restart. That might take time, and that might take a lot of time if your query store data is too much, right? Based upon your database size. If you do not want that to be incurred because you want your SQL Server to be restarted very quickly, right? So you can go ahead and turn off 7745 to make sure your SQL Server is quickly restarted. But at the same time, remember that you will be losing the query store information that is being captured in the memory for the interval length of minutes that you will be captured in the memory. Let's say for every 15 minutes interval, you'll be pushing the data. You will lose the 15-minute worth of data of query store. If you are not bothered about the query store information for that particular 15 minutes, you can enable this. But it is so important that our server will be online as quickly as possible. So that is the best option to enable the trace flag 7745. And there is also one more trace flag 7752. where it will enable the asynchronous load to the query store. And it is by default enabled on SQL Server 2019. So you can easily go ahead and enable if you have below 2019 versions. So what does this trace flag actually do? So whenever you restart the SQL Server and your databases are getting online, before even your database be online and available for the users and applications, or there will be some of the system data from the query store needs to be pulled into the memory. That might take time because during that phase of pulling the system information, query store information into the memory, it might take time. And during that time frame, the transactions will be in halt. You cannot do any transactions. That might cause some issue, right? You want your database to be enabled at ASAP and connections to be connecting to the database as soon as possible. To make that happen, you can actually asynchronously move the query store data into the memory once your database got online. Your database will be online and asynchronously all the query store information will be moved to the query store asynchronously. But during that time, the query store will be read only, right? It will just read the information, the force plan information. But then that is the best thing because the database will be online and all the users can be connected to the database. Natively compiled queries are not enabled, like, or not captured by the query store automatically. You need to go ahead and specifically enable syssp xtp control query execution stats. Again, once you enable this, it is not persisted. Once you restart the SQL Server, make sure you enable that again if you want to capture natively compiled queries. And if you're having many ad hoc queries, use optimize for ad hoc workloads can save the cache memory, but there are also other options for this. You can go ahead and clear out the information, the ad hoc queries information from the query store. There is a query in the Microsoft Docs where you can go ahead and run and clear out all the ad hoc execution information from the query store. Even that can also be done on the continuous basis. You can schedule as a job and you can do it as well. Max plans for the query is 200 execution plans per query by default. You do not have to accept the defaults, right? You can change it. And the maximum storage size will be once it is reached once it reaches 100%, your query store will be going to the read only mode. And later, if you observe, like, you will wonder why it has actually reached to read only mode, right? So please make sure to put the cleanup mode, size-based cleanup mode as auto, which will actually avoid query store to go to the read-only mode. Now you might be thinking why. We have already discussed in the session that once if you if you put this size-based cleanup mode as auto, which is by default it's turned as auto. But when it is in auto, once the 90% of the size has been reached, it will go ahead and clear out the oldest data automatically for you until it reaches 80%. So your query store doesn't have to go to read-only mode. So the auto mode, when you are in the auto mode, the capture policy, right? If you place that in the auto mode, it will actually avoid the ad hoc queries with small resource consumption. And by default, for the SQL Server 2019 and for the Azure SQL Database, the query store capture mode is automatically, right, by default. And QDS Toolbox is something from the channel advisor. They have they have some of the queries which are very useful. They have they have created these queries, querying the catalog views for the query store. They are the collection of the queries that are very useful and free to use. They have a GitHub repo, and this is a link for it. You can go ahead and use. Once you enable the query store on your databases, these are very useful queries. So check it out. And the best practices to know the best practices for the query store before even enabling, know what each of the options are, and for your workload what options are best to be enabled and how much you have to enable, like for example the size, right, based upon your database and workload. So to know all of that, just go ahead and read these Microsoft Docs. And even I have created a couple of uh, blog posts on my website, dbanuggets.com. Check it out as well. And I have followed Microsoft Docs to create this presentation. And if you'd like to know more about it, again, these are the resources you can go ahead and learn. All the pictures that I have used in this presentation are from pixels.com. It is completely free and free to download and use for your presentations. I would like to thank Jen Ashley for giving me this wonderful opportunity to present for Tech Now Day. I really appreciate you and thank you so much for taking your valuable time for attending Tech Now Day. I wish you all the best. Thank you so much.